Hello everyone, our focus for this video is the chain rule. We are going to look at how we use the chain rule to differentiate functions. Right? Now here on the board I have the chain rule that states that if you have a function y is equal to ax plus b all raised to some power, which is n, and you want to differentiate this function with respect to x, then dy by dx is equal to, you take the power of the function to multiply the entire function, subtract 1 from the function, and multiply that by the derivative of the inside of the bracket, which is a. So that's basically what this rule is saying. As I work these examples, you will get a full understanding of the chain rule. So let's look at the first example. We have a function which is y, right, equal to 2x plus 3, all of that raised to the 7th power. And you are asked to differentiate this function using the chain rule, then dy by dx is equal to, you take the power to multiply the entire function, which is 7, open bracket, 2x plus 3. You must subtract 1 from the power, so this is 7 minus 1, which gives you 6, multiply by the derivative of the inside of the bracket here, and inside of the bracket here is 2x plus 3. So when you find the derivative of 2x plus 3, that only gives you 2. You can simplify this to give a final answer of dy by dx equal 7 times 2 is 14, open bracket, 2x plus 3 all raised to the 6th power. And that's it. That is how you use the chain rule to differentiate a function. Let's look at example 2. We have y is equal to 2x squared plus 3x, all of that raised to the 10th power. You are asked to differentiate this function with respect to x. You must use the chain rule. Dy by dx is equal to, take the power to multiply the entire function, so this is 10 times 2x squared plus 3x, all of that raised to this power minus 1, so it is 10 minus 1, and that gives you 9, multiplied by the derivative of inside of the bracket. Inside of the bracket we have 2x squared plus 3x. So if you would differentiate 2x squared, you are going to use the power rule. So you're going to take 2 to multiply 2, that gives you 4. Put back here x, and then subtract 1 from the power, so this is 2 minus 1, that's just 1 here, plus differentiate 3x, that gives you 3, and you put all of this in a bracket, and that is your final answer. So let's look at the third example. Let's say you have a function that says y here is equal to the square root of x squared plus 5x, right? And you are asked to differentiate this function using the chain rule. One technique that you can use is to rewrite the function using up your laws of indices knowledge. So you could say that y is equal to x squared plus 5x, all of that raised to the power of 1 over 2. Now you just differentiate normally using the chain rule. So dy by dx is equal to, take the power to multiply the entire function, so it is a half, multiply by the entire function, which is x squared plus 5x, all of that raised to the half minus 1, so half minus 1 give you minus a half, multiply by the derivative of the inside of the bracket. So if you differentiate inside of the bracket, which is x squared plus 5x, Differentiate x squared, that gives you 2x. Differentiate plus 5x, that gives you plus 5. All of that in a bracket. And that's it there. So let's look at the next example. So our fourth example says y is equal to 2 over x plus 3, right? And you are asked to differentiate this function using the chain rule. Another technique that you can use is to rewrite the problem using laws of indices, right? If you put a bracket here, then this is just x plus 3 to the first power, right? Now you can bring this x plus 3 above. So the problem would be y is equal to 2 times x plus 3. But now it's not just to the positive one, but the power will change to negative 1. Right? From here, you just differentiate normally using the chain rule. So dy by dx is equal to, take the power to multiply the coefficient of outside. So here, negative 1 times 2 give you negative 2 times x plus 3. Now, negative 1 minus 1 gives you negative 2, right? Multiplied by the derivative of the inside of the bracket, which is x plus 3. And when you differentiate x plus 3, that only give you 1, right? And 1 times anything just give it back itself. But that's it there, right? So let's look at the fifth example, right? Let's look at the fifth example. Y is equal to sine x raised to the third power, right? And you are asked to differentiate this function using the chain rule. Then dy by dx is equal to, take the power to multiply the entire function, which is 3, right? Sine x, subtract 1 from 3, that gives you 2, multiply by the derivative of the inside of the bracket. So when you differentiate sin x, that only give you cos x, right? You can simplify this to be, or just rewrite it to be, dy by dx is equal to 3 sine squared x cos x. That's basically it. Now let's look at the sixth example. A function which is y is equal to cos 2x, right? All of that raised to the second power. And you are asked to use the chain rule to differentiate this. Then dy by dx is equal to, take 2 to multiply the entire function, which is 2 open bracket cos 2x, right? Subtract 1 from 2, that gives you 1, multiply by the derivative of the inside of the bracket, right? So when you differentiate inside of the bracket, right, you must differentiate 2x first. So if you differentiate 2x, that gives you 2, so that's going to give you 2. When you differentiate cos 2x, that's going to give you minus sine 2x, right? All of that in bracket. Now this is 2 times sine minus sine 2x, right? So we can further rewrite this to give us dy by dx is equal to, you multiply 2 times 2 here, that's just 4, right? You multiply cos 2x times sin 2x, which is negative sin x. I'm going to put the negative in front of the 4 here, and then just multiply cos 2x sin 2x. And that's your final answer there. Alright? Let's look at the seventh example. So you have a function which says y, right, is equal to the square root of tangent x. And you are asked to differentiate this function using the chain rule. First thing you need to do is to rewrite this function. So this function can be rewritten to be y is equal to tangent x raised to the 1/2 power. Right? Now, use the chain rule normally. So dy by dx is equal to 1/2 times the entire function. So this is going to be 1/2 times the entire function, which is tan x. 1/2 minus 1 gives you minus 1/2. Multiply by, when you differentiate tan x, which is the inside of the bracket, that gives you sec squared x. So that gives you sec squared x. Right? And that's it there. Now let's look at the final example. Y is equal to 2 open bracket sine x all raised to the 4th power. Right? And you are asked to differentiate this using a chain rule. Then dy by dx is equal to, take 4 to multiply this 2 here. So 4 times 2 give you 8. So that's 8 times all of the function, which is sine x. Take 1 from 4, that leaves you with 3. So that's sine x to the 3. Multiply by the derivative of inside of the bracket. When you differentiate sin x, that only give you cos x, right? Now you can further rewrite this to give dy by dx is equal to 8 sine cube x cos x without the multiplication sign. Alright? And that's it. Thank you for watching, and I hope that this video would have helped you in more ways than one.